Imagine navigating a city, only for your GPS to suddenly stop working. A shocking 1 in 3 GPS disruptions are caused by space weather. Now you might be wondering, what exactly is space weather? Well, it's a term used to describe the conditions in space that can influence the performance and reliability of our technology and systems here on Earth. This includes our beloved GPS systems. You see, space weather is primarily driven by the sun's activity. Solar flares, coronal mass ejections, and high-speed solar wind streams can cause fluctuations in Earth's magnetic field. These fluctuations can interfere with the radio signals used by GPS systems, leading to disruptions and inaccuracies. In essence, the sun's temper tantrums can play havoc with our navigation systems, and this is more common than you might think. So, next time your GPS acts up, it might not be a technical glitch, but a cosmic event millions of miles away. But what exactly is space weather? It sounds like a sci-fi concept, doesn't it? Well, despite sounding straight out of a Star Trek episode, space weather is a very real phenomenon that has tangible effects on our daily lives. To understand space weather, we first need to look towards the sun. Our star is a bubbling mass of plasma, constantly sending out a stream of charged particles known as the solar wind. This wind is not constant, and its intensity can vary, leading to gusts and storms in the space around Earth. Now let's discuss solar flares. These are sudden, intense eruptions on the sun's surface, releasing vast amounts of energy in the form of light and particles. Sometimes these flares are so powerful, they blast a cloud of charged particles into space, known as a coronal mass ejection. When these particles reach Earth, they can cause geomagnetic storms, which can interfere with our satellites and power grids. And then there are cosmic rays. These are high-energy particles from deep space that continually bombard our planet. While our atmosphere protects us from most of these rays, they can still affect satellites and other technology in space. But how does all this connect to our GPS systems? Well, all these phenomena, solar wind, solar flares, and cosmic rays, can interfere with the electromagnetic waves used by GPS systems. The charged particles they release can cause fluctuations in Earth's magnetic field and ionosphere, leading to errors in GPS signals. This can be as innocuous as a slight delay in your GPS navigation, or as serious as a complete disruption of satellite communications. So, while space weather might not mean rain or snow like the weather we're used to on Earth, it can still have significant impacts. It's a complex, dynamic system of energy and particles, constantly in flux, and it's all happening right above our heads. In essence, space weather is an invisible force field that can play havoc with our modern technologies. Now you might be thinking, a little GPS disruption isn't a big deal, right? But consider this. GPS isn't just about navigating from point A to point B, it's an integral part of our modern world. Let's start with transportation. Imagine airlines, ships, and freight services unable to accurately track their routes. A GPS glitch could result in lost cargo, delayed deliveries, or worse. Then we have the military, where GPS is used for everything from troop movement to missile guidance. A disruption could compromise missions and put lives at risk. And don't forget emergency services. Firefighters, police, and ambulance crews rely on GPS to respond to crises quickly. A delay of even a few minutes could mean the difference between life and death. So you see, the global impact of a GPS disruption extends far beyond your daily commute. A GPS disruption isn't just about getting lost on your way to the grocery store, it can have serious, even life-threatening implications. So, what are we doing to protect ourselves from these cosmic disruptions? Early warning systems. Scientists continuously monitor the sun and space weather conditions using satellites and ground-based observatories. Early warning systems provide alerts about solar flares, coronal mass ejections, CMEs, and other space weather events, allowing satellite operators and astronauts to take preventive measures. Radiation shielding spacecraft and satellites are often equipped with radiation shielding materials to protect sensitive electronics and instruments from the harmful effects of space radiation. These shields can be made from lead, aluminum, or composite materials designed to absorb or deflect radiation. Critical systems on satellites and spacecraft are often designed with redundancy, ensuring that backup systems are in place if one system fails due to space weather effects. Additionally, components may be hardened against radiation effects through design modifications or radiation-tolerant materials. During periods of heightened space weather activity, Satellite operators can adjust the orientation of satellites to minimize radiation exposure. For example, spacecraft may be rotated to place their more robust sides facing the sun during solar storms. Ground-based measures. On Earth, infrastructure vulnerabilities such as power grids and communication networks can be mitigated through measures such as improving the resilience of transformers and developing protocols for managing power fluctuations during geomagnetic storms. Scientists continually study space weather phenomena to better understand their impacts and develop more effective mitigation strategies. This includes using computer models to simulate space weather events and their effects on Earth and space-based systems. Given the global nature of space weather impact, international collaboration is crucial. Organizations like the International Space Weather Initiative, ISY, facilitate cooperation among scientists, engineers, and policymakers from around the world to address space weather challenges. While these measures help mitigate the effects of space weather, ongoing research and technological advancements are essential to improving our ability to predict and protect against these phenomena. Well, scientists are tirelessly working on strategies to mitigate the effects of space weather on our GPS signals. One of the key measures being taken is the advancement of space weather forecasting. By closely observing the sun's activities, researchers can predict the occurrence of solar storms. This early warning system allows us to take precautionary steps to protect our satellites and reduce the potential impact on GPS signals. In addition, technological advancements are playing a pivotal role. Engineers are developing more robust satellites that can withstand the harsh conditions of space weather. These satellites are equipped with advanced shielding and innovative software to correct any disruptions caused by solar activity. Furthermore, research is ongoing to understand the intricate relationship between the Sun and Earth's magnetic field. This knowledge will help us devise more effective ways to safeguard our GPS systems. While we can't control the weather in space, understanding it better equips us to prepare for its impacts here on Earth.